Welcome everyone to another short tutorial for operating system course. So in this particular section, we will be discussing operating system design and implementation steps, like what are the different steps involved in designing and implementation of operating system. And this is the part of chapter number 2. So this is the part of chapter number 2, operating system structures. So there are mainly three steps which are involved in operating system design and implementation. First is called the design goals. Second is called policies and mechanism. This is the second step of designing and implementation. And the last step is implementation. So let's look at the first step, which is design goal. So design goals, first of all, the goals should be very clear and concise. Like it should be specific goals that you're trying to achieve. And one of the biggest problem in designing a system is to come up with define the goals and specification. So when we look at the design goals, like what we are trying to achieve behind designing an operating system, there are two types of goals primarily. One is called user goals and second is called system goals. So user goals, as name suggests, what exactly user want, like user of the operating system want. And typically these are convenience, for example, fast, user want a fast operating system, a secure operating system, and easy to learn, easy to work operating system. While the system goals are the goals behind designing an operating system, which is typically flexible. We want a flexible operating system, efficient operating system, and of course, easy to design. There are many other design goals as well, like for example, reconfiguration, etc., etc. Secondly, when we come to so once the goals are clear, the second step is called policies and mechanism. So firstly, let's look at the policies. Policies are basically what we need to do, like what will be done in order to achieve the goal. So policies are basically what will be done or what is required in order to achieve the goal. So here we're going to have a specification clear. So it will basically provide a specification, like what sort of modules we need. Then the blueprint of operating system is basically the mechanism. So mechanism is called blueprint, or you can say mathematical modeling. So policies is like what we need. So for example, to design operating system, we will define to achieve these goals. We need, for example, these three things. Mechanism is how to implement it, how to get it done. So this is the mathematical foundation, like mathematical modeling, or you can also call it the pseudo coding. We're gonna get it done here. Now the actual implementation, this is number 2. Actual implementation will start in the last step. So firstly, you're gonna get a piece of paper, get the design goal ready, specific goal ready, then design goal is ready, then the policies, how to achieve the goals, and then the last thing is to achieve those goals, how to implement it. So the last step is implementation phase. In implementation, what do we do? So early on, the old operating systems like MS-DOS, they typically use mainly assembly language. So mainly they use assembly language and some sort of system programming language as well. Imperative programming languages like Go programming, which is high level of course, but system programming languages are typically used. But nowadays, the low level where we have CPU, RAM, hardware interaction. So we use assembly language. And we also use some VHDL in order to interact with assembly code. So the main body of operating system is typically designed in high-level programming language. High-level programming language mean, for example, C, C++, for example, Java, C#, and system calls and programs are also designed in high-level programming languages. All right. And again, as I mentioned earlier, high-level programming languages like these high-level programming languages are easy to configure, easy to code, but these are slow because they have to be converted into low-level programming language in order to interact with the hardware. Lastly, we also use a small we call it a small module which is called emulator. And emulator which basically makes operating system behave like another system. So in operating system, this is a very crucial component which makes a system behaves like another system, emulator system, when we do the implementation. So we will continue from here, and in the next part we will be talking about operating system structures. We will discuss Microsoft DOS. We will make a comparison of Windows with the Mac and Linux